Welcome to the session, folks. My name is Ankit Astana. I hope you guys and folks are enjoying Build this year. This is the last talk at Build, and we saved the best for the last. That's what we're really hoping for in this session. So let's get started. So before we go further, I have a question for the audience here in terms of how many folks in the audience are just getting started with machine learning? Can we have a raise of hands? Awesome. Thank you. So in this session, we're going to talk about how you can actually enter the world of machine learning with ML.NET 1.0. I'm joined here by my fellow PMs, Cesar and Chris Lauren.
Hi.
And we're really excited to be here today. So as you've probably already seen at Build this year, .NET is a great tech stack for building a wide variety of applications. You can build web apps in ASP.NET. You can build mobile apps in Xamarin. And in this session, we're talking about how we're making .NET great for machine learning with ML.NET. So let's go over very quickly what we're going to cover in this session. So we're going to start with giving you an overview about what's new with ML.NET 1.0. We're going to show you how you can get started quickly with ML.NET. Then we're going to get into some of the newer features we've added in 1.0, like the AutoML experience, the tooling experiences, which include Model Builder and the ML.NET CLI. And then we're going to get into how you can deploy ML.NET models at scale and also build deep learning models using rich open source popular libraries like TensorFlow and Onyx. So for those of you in the room who are perhaps new to machine learning, one way that you can think about machine learning is that machine learning is about programming the unprogrammable. So for example, if I ask you folks in the crowd, can you go ahead and build a function which takes in an image and returns whether this image has a face in it or not, you might not know where to start. If I take another example, where I give you a description of a shirt like the one I'm wearing right now, and ask you again, can you write me a function that returns what's the price of this shirt? In this case, you might be able to look at some keywords like long sleeves or business setting and try to guess the price of the shirt. But if I then go ahead and say that, hey, can you scale this up to 1,000 products in terms of what online stores sell, you might actually be a bit challenged there. So even though you don't perhaps know how to get started with writing these functions, what you do have in front of you is examples. You have examples of images with faces in them, and you have examples of images that do not have a face in them. And what machine learning is really about is learning from these examples and then building a function, or what we call a machine learning model, that you can then use. Another way about thinking about these machine learning models is that you can think of it as an intelligent function, which takes as an input as an image in this case, and then returns whether this image has a face in it or not. So with ML.NET, you can actually go ahead and build image classification models like the one I just showed you, which can detect whether there's a face in an image or not. You can build other models for regression, which help you answer questions like how much, how many. And while you're using ML.NET, what's the great value prop of ML.NET is that you can use your existing C# and F# skills to build these models. Even though we announced ML.NET 1.0 at Build this year, if you look at the history of ML.NET or the roots of ML.NET, they come from a Microsoft research project called TLC, which has been in the company for a number of years and is used extensively by products like Azure Machine Learning Studio, Azure Machine Learning, experiences like Windows Hello, Office PowerPoint, Azure Stream Analytics, and a whole lot more, to name a few. Since we're targeting developers with ML.NET, we've designed the framework in that manner. And with 1.0, we're adding some new features like AutoML and tools like Model Builder and a command line interface, which will help you make really easy for you to build custom machine learning models. We've also, from the get-go, thought of extensibility as a key point or key value prop or key design principle in ML.NET. So not only can you leverage and use the ML.NET trainers and the ML.NET transform that it comes with out of the box, but you can also benefit from using open source popular frameworks like TensorFlow or Onyx using the same uniform API set that ML.NET offers. And just one more point on this slide that I want to kind of make is that, like everything else in .NET these days, ML.NET is free, it's cross-platform, and it's open source. So that sounds great. Let's talk about perhaps what are some of the things you can do with ML.NET 1.0. So there's a number of things that you'll see on this slide that you can already do. You can build sentiment analysis models. You could build a product recommender. You could do price prediction. You can classify images. You can build a sales forecast, and a whole lot more. All of these scenarios that you're looking at here are available. There are samples repo. So let me just walk you there. So what you're going to see here in a minute or in a second is the .NET website. So if you're looking for ML.NET, you can click machine learning section on our website and arrive at the ML.NET landing page. If you go further, you're going to see these various samples that we have. And clicking any one of them is going to take you to our samples repo, where you can learn how to build them from scratch. So let me just show you the samples repo very quickly. So here's our samples repo. You can see here we have samples for fraud detection. You can classify issues. You can recommend products. You can do a sales spike anomaly detection. And you can also use TensorFlow and Onyx to do things like image classification and object detection. For each of these samples, for example, fraud detection here, we have both the training code for these models and the consumption code. So you can see here in each one of these samples, we describe you where the data set comes from, what kind of machine learning task the sample represents. And then we show you the code for building the model and then consuming the model. So if you're new to machine learning and you just want to get started, chances are, if you visit our samples repo, the scenario that you want to actually go and enable is perhaps already there. And this will be a great start for you just to look through these samples and learn. So next, perhaps let's take a scenario here and like sentiment analysis. And let me show you like a live app that uses this. So what you have in front of you here is a Blazor ML.NET app. So this is using Blazor, and the model that's running behind it is an ML.NET sentiment analysis model. So let me just go ahead and type some stuff here so you can see this in action. So if I say machine learning is fun, you can see that that's a very positive sentiment, so it's working well. However, if I go and say that, hey, machine learning is not fun, you'll see that the sentiment there drops. So that's a very simple example of ML.NET at play. So what if I want to build this sample from scratch? So let me show you how you can do that. So I'm going to bring up Visual Studio here. This is Visual Studio 2019, but you can use any version of Visual Studio to play with ML.NET. The first thing that you want to do when you're getting started with MLNet is that you want to go ahead and acquire our NuGet package, which is called Microsoft.ml. Once you've acquired that package, you can see all our source code is currently under the Microsoft.ml namespace. So if you want to go ahead and check that piece of code, you can certainly go ahead and do that. Once I've set up my NuGet package and my namespaces, I can go ahead and start creating my machine learning context. For those of you in the room who are familiar with the entity framework, this is very similar to creating a DB context. So the next thing I have to do is, once I've created my context, is to read in my data set for training and testing. So if you notice over here on the right side in Solution Explorer, you're going to see that I have two data sets here. I have the Yelp label trained data set and the Yelp label test data set. If I go explore one of these data sets here, you're going to see that this has two columns. The first column is column text. This is the actual text. And the sentiment column is the second column, which is of value 1 or 0, which represents whether the sentiment is good or not. So for example, if I say something like, overall, I like this place a lot, the sentiment on that one is positive, and that's what the value 1 is suggesting. So the way I read in this data set into my ML.NET environment is by using an input class. In this case, I've already created my input class, and it has two fields. The first field is of type text, it's called text, and is of type string. And what this is representing and mapping is the first column here in this data set. The second field is called label, and that's at column index 1. And that's of type Boolean because that's representing whether my sentiment is positive or negative, which is 0 or 1 in this case. So now I'm going to go ahead and use this sentiment input class to go and read in my data. So I'm going to say iData view here. I'm going to pass in my input class here, which tells us how to read the data set. And then as parameters, I'm going to pass it the path to my training data set, and then a parameter here, which basically tells it that, hey, I already have a header. While I'm at it, I'm also going to go ahead and read in my test data here very quickly. So I'm going to use my training data to train my model, and I'm going to use my test data to determine how well my model is actually performing. So at this point, I've read in my data sets. So now the way machine learning works is that when I've read in this data right now, the text column here, this particular column or text in general needs to be converted to a particular format that certain machine learning algorithms can understand. So what I need to do here next is take this textual column or string column here and then create an integer, create a vector which is basically of type ints, essentially. So the way I do that in ML.NET is by creating an estimator pipeline. So I'm going to say, in step 2, build an estimator pipeline which transforms my input data. And once my data is in the right format, I can actually add an ML trainer to it. So I'm going to say var, I'm going to say iEstimator, iTransformer. I'm going to build this estimator in a stepwise manner. So in the first step, I'm going to go ahead and say transform. I'm going to transform my text. For this transformation, I'm going to use this transform called featureized text, which uses something called n-grams. This takes in the output column, which I'm going to call features. This is where my result of the featureization will be. And then I'm going to pass in as an input the first column, which is of type sentiment.text. So all I've done in this line of code is I've taken my input text column and then converted that into a featureized text column using this transform. Once I've done this, I can now go ahead and add a trainer to this. So I'm going to say .append. Since we are trying to essentially perform sentiment analysis, since we're trying to predict whether the sentiment is 0 or 1, that's an example of a binary classification problem. So I'm going to set binary classification as a part of my context. And then I'm going to say trainers. And now what I can do now is I can choose among one of the many trainers that ML.NET provides. This is what IntelliSense is currently showing me. In this case, I'm just going to use logistic regression. And I'm going to pass in as input here the label and the features column that I just converted or transformed. All right. So now I've built a pipeline that can actually take an input data, transform it into the right format, and then I've added my machine learning algorithm. In this case, that's logistic regression. The next step here is to train my model. The way I do that is by calling the fit API on the estimator and then pass in the training data that I just loaded. What this will do is it will actually go run the training data and then produce me and provide me a trained model. Once my trained model is ready, I can perform some predictions. So that's my next step. I will say var predictions equals model.transform. And I trained my model on the training data, but I want to perform transformations or predictions on new data. So in this case, I'm going to use my test data, which I loaded earlier. Once I've performed the predictions that I need, I can go and see how well the model is working. So I'm going to evaluate the model, and I'm going to store it in this var called metrics. As I'm going through this process, I'm going to use the binary classification evaluator because that's my machine learning task. And I'm going to pass in my predictions that I just got, and then the label in the score field. So that's pretty much all I kind of need to do to be able to build a sentiment analysis model here. I start with loading my data. I then convert that into the right format, add a machine learning algorithm, train my model, do transformations on new data, which is test data in this case, and then I finally go and evaluate this model. At this point, I'm going to just set a breakpoint here and run this in the debugger, so I can show you what kind of accuracy we're getting with this model. So I'm going to step over here. And what you're going to see here is that under metrics, you're going to see an accuracy field. So this accuracy field is telling you how well this model is performing. 0.80 is suggesting that this model is about 80% accurate right now on the test data, which is not bad, given we just got started. One last thing I want to quickly show you as well is a concept that we came up with. This is a convenience API called a prediction engine. And what the prediction engine allows you to do is it allows you to predict on a single instance of data. So I'm going to, the last step, create this prediction engine and say predict on single instance of data. So I'm just going to say prediction engine here. The prediction engine takes in, again, the input class, sentiment, and the output class. And then it takes in as input the model. Once I've created the prediction engine, now I can use the prediction engine to make a single prediction. So I can say prediction engine.predict. And now I can pass in a new sentiment to it. And I'm going to call this new sentiment the same one that I tried on the app, that machine learning is fun. I'll reset my breakpoint here, so I can just show you how this prediction actually works, or how this prediction is doing. So if I just step over this code, what you're going to see in the debugger here is that the prediction for this particular sentiment is positive, and the probability and score are just telling you how well this prediction is. So that's a very quick example on how you can get started with ML.NET to build a sentiment analysis model. So hopefully that makes sense. If some of these concepts seem a bit strange to you, do not worry. We're going to cover this at length in our deck here. So the next thing I kind of want to cover is, so I already covered that one. So the next thing I want to cover here quickly is what are some of the new features we're adding with ML.NET 1.0. So the first thing I want to talk about is AutoML, or automated machine learning. This is a new feature that we've added. So if you just remember the coding example that I went over, when I went ahead and chose a binary classification trainer, what you might have observed is that in ML.NET, we have a number of trainers there. We have average perceptron, we have linear SVM, we have logistic regression, and so on. So now, as a person who's starting new with ML, this might be tricky to see which one actually performs best for your scenario. Likewise, even if you've kind of like figured out the right trainer for your example or for your scenario, you can further fine-tune these trainers with these settings called hyperparameters. So again, if you're starting with machine learning and you're new, this might be really challenging for you. But with AutoML, we kind of like solve this problem. So AutoML automatically builds these models with the best performing trainer and settings for you. So it's going to use your local compute to figure out the best combination here and provide you the best performing model. You can run the AutoML experience that we have locally, and we currently support 3 tasks there. We support regression, binary classification, and multi-class classification. You can use the AutoML experience that we built in ML.NET in 3 different ways. You can use the model builder tool that I'm about to show you next. You can show the ML.NET CLI. You can use the ML.NET CLI, which Cesar is going to show you. And then we also have an API for ML.NET AutoML that you can try out if you want to build models on the fly. So the next thing I want to get into is the tooling experience that we're providing you for ML.NET. So we also announced at Build this year a new tool called the ML.NET Model Builder. This is a Visual Studio extension. And what this tool does is that it's a very simple UI tool that allows you to build these custom models automatically using AutoML. Along with generating the models, what it also does for you is it generates code for both model training and consumption. You can check this tool out at our AKMS link, .NET Model Builder. So let me just show you this tool in action. So The way you can launch this tool is by right-clicking Add and clicking Machine Learning here. If you want to figure out where you can grab this tool, you can go to our website here very quickly. It's just .NET ML, and you can click the Model Builder link. This will take you to the Model Builder page, which shows you the different features of Model Builder, and also allows you to download the Visual Studio extension for it. I've already downloaded that extension, so I don't need to do that again. So this is the first screen in Model Builder. The first screen here will show you the different scenarios that you can solve for machine learning using this tool. We have two examples here for price prediction, which is an example of regression ML task, and sentiment analysis, which is an example of a task binary classification. But you can also build other scenarios using the custom scenario template here. I'm just going to go ahead and click sentiment analysis so I can show you this tool for now. The next screen is basically about data. So this screen will allow you to load your data. We support loading both file and SQL. Since I've already shown you how to load a file and use a TSV or a CSV, let me actually show you SQL. I'm going to connect to an Azure SQL database here. Choose SQL auth. Let me actually just do that again. It's going to come back, hopefully. All right, so let me just log in again here in SQL. I'm going to try that again. Thank you, Pranav, who also built this database for this demo. So we've just logged into our database, and now we can actually pull in one of the databases. I'm going to pull in the same data set that I used to build the sentiment analysis model earlier. So this database is called Yummy Food, and I'm going to click OK. I can then choose the table. In this case, I'm going to choose the same sentiment review table. And what this tool is going to do is it's going to show you a preview for what you would see, essentially. The next task that this tool asked me to provide, or we need to choose, is the column that we're going to predict. So in this case, we're trying to predict the sentiment. So I'm going to choose the sentiment column as the column I want to predict. Once I've done this, I can go to the next phase, which is the training phase. I'm going to go ahead and train for about 30 seconds here. And as this tool, the model builder, is actually training, what you're going to see here is at the bottom here is the accuracy of the model that it's got so far, the best algorithm it has chosen, and the different algorithms it's trying out. So the more time that you provide this tool, the more time it has to be able to traverse different algorithms and explore different models for you. In this case, my data set was fairly small, but if you have data sets that are bigger, for example, if you have a data set that's more than a gig, that might take a couple of hours. If you have a data set that's about a terabyte, that might take a couple of days. We've tested it for both scenarios here. So in this case, I just trained this model for 30 seconds, and you see that the accuracy it got here was 86%. If you remember from my last example that I did when I created the sentiment analysis model by hand, that only had an 80% accuracy. So using this AutoML experience, you're already seeing a better accuracy here with just 30 seconds of training. Once my training is complete, I can go to the next screen now, which is the evaluate screen. The evaluate screen will allow you to look at the best model performance, the different models it explored, and so on. If at this step you're unhappy with the performance that you got or the accuracy that you got, you can go back and you can train for longer, and that perhaps will result in a better accuracy. Or you can essentially add more data to the problem and so on. The last step here that the model builder allows you to do is it also allows you to generate code automatically. So when I click Add Projects here, what that's going to do is it's going to create two projects. The first project here that it creates is a class library. And what this class library has is it has the model.zip file, which is the trained model that I just trained in the tool, and it has the input and the output class. Along with the model and the input and output classes, we also create another project here, which has the training code and the consumption code. So if I just show you the training code very quickly, you can see here that this is essentially doing the same featureization that I did by hand earlier. But in this case, it actually found a better performing learner, which is linear SVM. It also found these hyperparameters, which provided the best performance. So you can see how the AutoML experience is helping you create the best performing model. The other file that you'll see in this project is called the program.cs file. And what we are showing in this file here is how you can now use a trained model. So you start with, again, creating your context, and then you load the ML.NET model here. You create the prediction engine again, and then you can start making predictions. I'm just going to hijack this code a little bit here and add my own single instance of data and say new I'm just going to cheat a little bit here and see what the input here is. The field is called sentiment, so I'm going to go back here and say new sentiment. And I'm going to actually set this to be the same thing I tried earlier, which is machine learning is fun. Let me try this again. So if I run this now, and I set my breakpoint here, what you'll see is the generated code that the model builder created for me. And then now I'm essentially using that generated code to make a single prediction. Let me have to run this. And we're going to see in the debugger here again is that if I go to the prediction metric, you'll see that prediction again is true, and you can see the probability and score associated with it as well. So that's kind of like a very quick demo on what Model Builder can do for you. Model Builder is in preview, and we are looking for feedback on this tool. But hopefully, this makes building machine learning models easy with ML.NET. I'm going to switch back to the deck here quickly. And the next thing I want to show you is a couple of other tools. But for that portion of the talk, I'm going to leave you with Cesar, who's going to cover this. Thank you very much.
Thanks a lot, Anki. Cool. That was an awesome demo. So now what we're going to see is another approach, another tool that we created using AutoML. But instead of using Visual Studio, there are other users that might want to use the CLI, the command line interface, for various reasons. One could be because this is cross-platform. You can run the CLI on Mac, Linux, or Windows. And another reason is because once you know the process and maybe you want to generate a model every day or with new data, or you want to automate with the CLI in a different pipeline or whatever, then it's very useful to have also a CLI, right? So let's see a demo about it. OK, so here I have Windows. In this case, I'm going to run it with PowerShell, but you could run the same demo on a Mac or command line as well, or Linux. And the way you get the CLI is basically this CLI is a global tool. So you install it as a global tool, like you can see here, with .NET tool installed, and then MLNET. And MLNET is the name of the NuGet package that you will get automatically installed. And I just did this, so I don't need to do it now. And then the other thing I want to show you is also how it works. Like you can write MLNet, auto-train, and then task. And now we have also tab auto-completion, so I can press tab and see the different ML tasks that are supported right now, which is binary classification, multi-class classification, and regression. And in upcoming versions, we will add in the rest of the ML tasks that we have in ML.NET. So let me run one sample using the same very similar data set that we were using. Basically, you can see here MLNet auto-train. The task is binary classification. Then the name of the code or the folder is going to be sentiment model. The name of the data set is labeled TSV, so it's a text file with tabs between columns. And finally, I need to provide the label column name, which is what's the column I want to predict, I want to use as target, right? And finally, the time that I'm going to be looking for better models. In this case, just 15 seconds, because it's a quick demo. But when you're working with large data sets, you might need many minutes or even hours, as Ankit mentioned, right? So you can see it's sweeping. It's looking for better algorithms, and you can see the best accuracy so far was 87. And finally, you get a summary with five best algorithms. The best one in this case, in 15 seconds, was LBFGS logistic regression. You can see here the accuracy and other metrics like area under the curve, and you can get more information about these metrics in this URL that we have here. And most importantly, we are generating the code and the model, the zip file model that was created when training, and the code for training it or for scoring. Something that maybe was not clear when doing the demo previously, once you have trained a model, then you can save it as a zip file. You can serialize that, and you will load that from your end-user application, like a web application, desktop application. So that's that file, the mlmodel.zip file, and then the code. So the code is pretty similar. That it was generated here. You can see that now we have this folder, which is it's new. I was just starting with the TSV. So this is being generated, and then we have the same projects for the class library and code for training and scoring. It's exactly the same that you saw with Visual Studio. And it is the same because Visual Studio is doing that on top of the CLI. So we are consistent. In reality, it's the same thing, right? So let me go back to the next section, which is about scaling and going to production. Okay, so far we've seen how you can train your model, how you can test it, validate it, but what about putting this in your real applications, right? In .NET applications, ASP.NET Core applications, or ASP.NET. We support .NET Framework, .NET Core, and so it's also cross-platform. You can run the model on Linux, Windows, or Mac, right? So when moving to production, it's not just about preparing your data and building and training. The important point is also about running that model in your application, right? So you might have questions like this, like how can I optimize that for running in an ASP.NET Core application, for instance, scalable, multi-threading, or how can I include the creation of that model that we were seeing with Ankit into my DevOps, into my CICD pipelines, and how can I automate that, right? So let me do one demo about how you can use a model into ASP.NET Core application. So 8. So here you have a solution where I have a web API that we'll take a look in a minute. And then we have two projects that those are precisely generated by the CLI or Visual Studio. You see the console app for training model and the model project that has a zip file and the data classes that Ankit was showing. So I'm not going to show that later, maybe when doing unit testing. But now I want to focus on how can I use this model zip file into my web API, right? So there are basically three classes that you need to use when running a model. One is the ML context, as Ankit said. the I-transformer or model. Okay, so those are thread safe. You can put it as singleton or static, and would be better for performance. You can reuse it from different threads in your application. But the third object is the prediction engine that we also talked about for doing single predictions. And that object is not thread safe. So you need to use it in a special way when you are running a multi-thread application like ASP.NET Core. So this is what I'm going to show you in the Web API. You can see that I have copied the zip file for the model. I also have the data classes for reading and using the model. And what we did is, because doing this in a scalable way, you might need to use object pooling for the prediction engine. That might be complex. I wrote a blog post about that and how you can do that, but it's kind of complex. So what we did after a meeting a few months ago, in collaboration with the ASP.NET team, with Glenn Condron and Ryan Novak, is, hey, let's create .NET, ASP.NET extension package so you can use it in dependency injection in ASP.NET the same way you can use, for instance, SignalR or Entity Framework. So then you can, and it's going to be scalable, right? So it's super easy. You go to the startup class, and the configure services, and just need to register the prediction engine pool with the same classes, data classes that we were mentioning when creating the model, and then loading from a file, which is the path to the zip file. Okay, so we just register that as you would do a similar thing with Entity Framework. It's in the dependency injection container. And finally, you just go to your controllers, and simply in your constructor, you will get the prediction engine injected, and you just need to go in the method of your controller, predict sentiment, and just predict with the data, right? So I'm going to run it very quickly. But you can see it's just as easy as, hey, use dependency injection, get the object, prediction engine pool, and call predict with the data that came from HTTP. So for instance, you can see here that we are sending this data. MLNet is awesome, and it's saying positive sentiment, the probability for that text, okay? So that's the, let's move on. The demo I wanted to show about the Web API. Another thing is about CICD and DevOps, right? So because it's not just running this in production, you also want to be able to have a consistent code with the model that was trained with particular data. And for that, you need to engage this creation of the model in your pipeline. So I'm going to do a demo about that. I'll try to do it quickly. So basically, I'm going to start from a trouble case, which is I have a few Azure application web apps in Linux, Windows, where I want to deploy that Web API. But then one of my peers, they changed the data set, and pushed that into GitHub, and even deployed that maybe directly from Visual Studio into Azure. And the thing is that right now, the Web API is working. You can see this is URL in Azure, deployed in App Service, is working wrong. Like you see, the text is MLNet is awesome, but then the positive sentiment is false. And if I say the food was horrible, the positive sentiment is true, which is wrong, right? So I go ahead, and I can go to my build pipelines, and yeah, it looks like when the wrong data set was published, I'm getting errors here. And I can see that I have quite a few tests that didn't pass. So at least I can fix this. So what I'm going to do while explaining the code is I'm going to trigger a new build by providing the good data set. So I'm just copying this data set, renaming it. and then I'm going to push it into Git, which is where I have the data set. Demo push good data set. So now it's going to be in GitHub. And since I have configured continuous integration and continuous deployment, then it's going to trigger this build. If I go back to my build, it should be here. You see here is starting. This is going to take a couple of minutes. So while this is working, first of all, I want to show you the code about the tests, which is interesting. So in this case, the unit tests that I have here are testing the model. So one test that you can do, you can see that you can run these tests here. One test would be about simply testing that the statement, the negative statement with a wrong, with a bad sentence or negative sentence is doing it right, like this one. This movie was very boring, then it's going to predict false. Or this one, this ML.NET is awesome, is going to be true, right? Other tests, and even more interesting, is I'm loading the model, and then I'm getting the metrics, like Ankit showed, and I'm saying, hey, if the accuracy is not higher than 80%, consider this like it's not passing the test. So break the build, okay? And even further, you can also get a lot of hundreds of records and just test all those and show it here, right? So this is what we are doing precisely in the build. I want to edit then the build just to show you a few steps of the build. You can also do it with the new YAML. Probably I would do it in YAML instead of the tasks here, but because then you have the YAML in the same GitHub repo with the code kind of consistent. But for a demo, it's better to show the different tasks. But basically, in the build, you need to build a console application for training, train the model. Then we build a unit test project, run the unit tests, copy the zip file that was generated with the application building the model into the web API. We build a web API, and finally, we publish it as a pipeline artifact. And we can go and see if this is finished. OK, it's finishing. And then right now it's finishing. And now in a few seconds, you see that I'm going to see the test. That pass, and then it is starting and triggering also a release. You can see it was triggered because of the artifact, and we can see this release that is now publishing the web API into my staging environment, which is two different Azure App Service, one in Linux, one in Windows. And when this is done, then it will ask me if I want to go to production. But then in this case, I have to have a manual approval, right? So it's going to finish in a minute. While it is finishing, I just want to show you the pipeline for the release. And you can see that I'm deploying into a web API, into App Service for Linux or for Windows. And finally, let's see if it finished. OK. So it's published already in the QA. In production, it's pending approval. I could approve it. I'm not going to do it. And then I just refresh. And you can see running now the API. I'm going to refresh this one as well. And now the sentiment of ML.NET is awesome, true, running in Azure. And the same thing here. Now food was horrible is false. OK? And that's it. Thank you.
That was awesome, Cesar.
So we've covered a lot of text and numeric data types that you're already pretty familiar with how to work with. Hopefully you've seen how we can add some intelligence to your applications. Now I'm going to show you how we can use our preview features of ML.NET to incorporate pre-trained deep learning models into your applications to be able to work with other data types like images and speech, audio, and more. We can currently support taking in pre-trained TensorFlow models and ONNX models. Now, ONNX, for those of you who are not aware, is an open source initiative that we've partnered with folks like Amazon, NVIDIA, Facebook, and many hardware providers like NVIDIA, Intel, and others to be a cross-platform industry standard representation of trained machine learning models, which means that any machine learning models that are trained in scikit-learn or TensorFlow or PyTorch, et cetera, can be converted to ONNX and therefore used inside your .NET applications by way of our ONNX integration. So I'm going to show you how to take pre-trained TensorFlow models and ONNX models into your applications. So many of you have probably seen examples of using deep learning before, where we use a classic pre-trained model that's available on the web to just simply download. This one's called YOLO, you only look once, and it's an object detection example. I'm showing here in ASP.NET App, and we can select different images, and it identifies some bounding boxes, identifies what's in those bounding boxes, and tells you the probability or the confidence level that yes, this really is a sheep, for example. Now, I'm going to show you how to actually build this here in Visual Studio. Now, just like Ankit and Cesar showed you before, we'll start with an ML context. And even though we have pre-trained machine learning models, in this case, the ONNX YOLO model, you're oftentimes going to need to do some pre-processing or transformation of your data before feeding it through that model. So ML.NET not only enables training custom machine learning models and using them in your app, but also all of the required pre-processing steps necessary to use these deep learning models. So you can see we'll first load the image, just like we loaded text before, and to fit the model into fit the data into what the expected node is of this deep learning graph, we're going to need to resize the image, extract some pixels, and then we'll apply the ONNX model. And then afterwards, we'll use the same prediction engine that we saw before, which simply takes in an image data and returns a result. So this prediction engine, therefore, fully abstracts all of those other pre-processing steps. And you can then share this, publish this as a NuGet package and whatnot, so that you can use it in many other types of .NET apps, like Azure Functions, et cetera. Now, I'll show you also how to train your own custom vision model. I'll toggle back over. Oops, I closed this. Let's load this guy back up. So I'm going to show you how to do something called creating a model ensemble, which uses a pre-trained TensorFlow model as a step in this pipeline process to actually take in some images that you would find on a regular grocery store in this case. Now, the TensorFlow model that I've included in this app was not trained on images from a grocery store. Rather, it was trained on a lot of regular everyday objects like images of bikes and trees and cars and people and stuff like that. And we used a technique here called transfer learning, if you will, where it takes all the knowledge that you've learned in one context where somebody else has trained a model for maybe hours or days on lots and lots and lots of data, and using that in one part of your ML.NET pipeline to train another model that's specific to your task. In this case, I've used a bunch of different data from the grocery store to train a model that sometimes is pretty darn good, and sometimes, like this one, well, I don't really know if it's soda or not, because some of the cans of soda, some of the types of soda look a lot like bottles of juice, And so the model might get a little bit confused, but it still has pretty darn accurate. So we can see this one's definitely juice, this one's coffee, cake, etc. So to train this machine learning model, what we'll do here is we'll load from an enumerable. So just like when we loaded from SQL Server before, you can connect to pretty much any kind of data source that you would like to using the load from an enumerable. In this case, I'm going to enumerate over all of the images that we have in these different folders. So you can see I've got one folder per class, so cake, flour, candy, cereal, et cetera, and I've got a bunch of training images in here. Now, it's the end of the day. I've been here a while. I'm thinking about coffee. OK, so here's some coffee for you. So this is the input for training our new model. And so it's going to load these up. And then it's going to iterate over these. It's again going to load the images, resize them, extract the pixels. And here is where we'll load the TensorFlow pre-trained model using the input model location defined above. And then we'll train an additional multi-class classifier on top of that using the output of that TensorFlow model as the input to this classification layer. Then finally, we'll output the zip file just like you saw before. And when we run this, then I've loaded it ahead of time just for speed purposes. But you can see we can iterate over all the different classes, print out how many samples of each one of these classes. Now, if the model is not predicting well on one of those classes, just like Cesar showed you earlier, usually you'll need to debug your data, not debug your code. And so you might add some additional pictures into one of those folders to get more samples of one of those classes. Then we'll load up the TensorFlow model, we'll train the classifier, and then we'll output the zip file. Just like Ankit showed you earlier, ML.NET enables printing out the classification metrics, the quality score, if you will, easily. And then you can run through some samples to get the score in the command line here or inside an NUnit test harness, which you saw before as well. So we just iterate over a bunch of these different images in the test folder instead of in the train folder, because you want to make sure that you're testing with images that your model didn't see while training. Otherwise, you might overfit the model, which would be bad. So I can certainly publish this using Azure DevOps and proceed down that path. But I want to go into a little bit of detail covering one other topic, which is model explainability. So interpreting these machine learning models can be pretty tricky. A lot of you are pretty darn familiar with how to test an application. But testing a machine learning model can be tricky. Explaining how it works to somebody else in a way that you sound competent is even trickier. So there's some pretty standard techniques in the industry that enable you to do this so that you can explain and debug your models. But more importantly, many of you I know work in industries where there's regulatory requirements, whether it's in like financial or healthcare or whatnot. And oftentimes they won't let you ship something to production unless you can print out something explaining exactly how it works and why you believe it's good. Additionally, here at Microsoft, we've spent a lot of time and energy making sure that the data sets that we use training our machine learning models are fair and not biased. And so you can use tools like this to explore the data and understand why the model is predicting the way that it does, so that you can determine whether it's using characteristics of your data that it shouldn't. Whether it's age, gender, or many, many things that the model probably shouldn't take into account at inappropriate times. So by running through either both a kind of a global set of data or on a specific prediction, there's different techniques in ML.NET to enable you to understand what's happening. So here you can see an example in healthcare. If I'm going to predict a quality score for how healthy an individual is, and I simply tell that individual, hey, you're 82% healthy, they're probably going to look at me like, buddy, what's wrong, right? So you'd want to return that kind of explanation also and say, okay, well, here are the characteristics that you could improve. This is why it predicted that you are not 100% healthy, right? And when training or debugging your model, you might look at all of the data in the data set to understand the distribution of the features and their relative importance in training that model. So I'm going to show you exactly how you can do that with ML.NET. So I have built an extremely fancy WinForm application just for fun. I hadn't done it in a while. But you can see using the New York City taxi fare data set, because it's a very simple data set to understand. Most folks have taken a taxi trip before. And there's data in this data set that's like the length of the trip, the distance, as well as time, and how people paid, whether it's cash or credit card, and other features as well. And so on a per trip basis, then we can load up the test data set and then iterate over the different features in this particular model to understand why it predicted the fare is going to be $10. Well, the trip distance was super, super important in this one relative to the other one. But for some of these, then the different features like trip time and trip distance are relatively both important. And then others sometimes, you'd say, okay, well, on this particular trip, the trip time was a little bit more important than the trip distance. I can only imagine somebody had the cab driver wait while they go and grab their bags or something like that, and they charged a waiting fee or something. They didn't go as far, but it took a while. Maybe it was traffic, I don't know. But the point is that on each individual prediction, then you can get an understanding of why it performed the way that it did. And so to do that, then, of course, as I mentioned, we've got our data set here. And just like we've done before, we'll load up the data. We'll do some transformation, like one-hot encoding, and we'll normalize the data a bit. And then once we've trained the model, we can add one final thing here, which is the calculate feature contribution. And calculating the feature contribution is what's going to return that explanation of why the model performed the way that it did. Additionally now, when we train this model, then not only will it include that particular step, but then we can also run through, and we can kind of load up some test data set. We can see how this is actually transforming the data. Remember I talked about one-hot encoding and normalization. This is what the computer actually sees there, is these individual ones and zeros and all that sort of stuff, which is a lot of fun. And then we can go ahead and plot a chart that shows the kind of the relationship between how the ML.NET model predicted versus how well it actually performed. And my chart's not coming up for some reason, but that's fine. You've seen plenty of charts and stuff already. It's just a linear graph. So hopefully that gives you an understanding of how model explainability can help you step through, debug your code, your model, and understand your data so that you can explain to others why they should trust it. Where did we go on our PowerPoint slide here? All right, beautiful. So I want to thank you all. The journey for ML.NET from 0.1 last year at Build to 1.0 today has been pretty fantastic. There have been a whole bunch of downloads, a whole bunch of commits from a whole bunch of people in the community. It's been really fantastic to work with you all on creating a machine learning model framework for .NET developers. there are a number of customers that are using it in production today that are getting great results. They made it super easy to incorporate machine learning into their .NET applications, deploy it in Azure just like you can with any .NET application. And automated machine learning capabilities hopefully are a great way to get you started like they have some of our other customers. Because I know that learning this machine learning stuff can be pretty tricky, but their tooling should help make it easier. We're going to continue to ship regular releases. We're going to continue to improve our capabilities that we've just talked about. Some of them, like the model builder and the automated machine learning stuff, is in preview right now. So we're, of course, going to continue to improve it and get it to GA. We want your feedback as quickly as possible. Go out and try it today. We're going to make it easier to train your models and scale it out on Azure and add support for new types of tasks in machine learning. So we want to hear your scenarios to figure out exactly what we should include in the next set of releases. Get started today. Go to .NET/ML, read up on the docs, reach out to us. We'll help you figure out how to achieve your goals with machine learning. Happy coding. Really appreciate you all staying here so late in the day. I want to thank Ankit and Caesar for their time as well. It's been fantastic working with you all, and we're looking forward to continuing.
Thank you.